All right, so just the syntax right here, go and open that one up. So we'll work from this one, but again, what's going to make it easier is that it already has everything in there. The only thing that will need to be changed is variable names as well as the location of the file. So obviously your desktop does not have the same Auburn ID as I do, so that's something that will have to be changed. But other than that, it's going to be pretty similar. We're going to start with the spreadsheet for today. So if you open up that spreadsheet under April 17th, you're going to notice we have the same variables as last week, plus an additional one, maybe. And here's one extra there. Should look like this. So we're going to add a variable of calories in there. So again, if we're looking at health, again, this is self-reported health. We may be interested in knowing if calories will matter as well. And this is in hundreds, by the way, right? So calories. It's in hundreds, yeah. So in other words, it's 1,800 calories in a day, right? So just because zeros have been cut off. So just keep that in mind. It's in terms of hundreds. Okay, so if we're going to get this ready for M+, what do we need to do? Let's start there. Yeah, we do want to get rid of the titles, but before we do that, we probably want to make sure that they are in a code book, right? So if you haven't, open up a code book. You can open the code book from last week, that's fine. Then you do want your variable names in the order that they're in your spreadsheet. But you know that this is going to be your first column, this is going to be your second column. You know, I don't even know why we do this like horizontally here. It makes more sense if we did it vertically, turn the page sideways or something like that. But this is traditionally what we do. You see it in SPSS as well, right? You have your data file, your data stream, which is all variables in columns, and then you go to the data view, and the variable view, and they're now all in rows. So it's standard practice, but it doesn't make much sense to me. But anyway, so we do need to add a variable in here. If you left click and hold and highlight that last column, you can insert a row below. So insert below, and that'll give you another row there that we can put in our next variable. So we can call this calorie. Again, we don't want to go over 8 characters for the name. A description, we can say number of calories. You can say something else, but something along these lines. Number of calories consumed in a day. We'll say in terms of 100, you say hundreds, whatever you like to do. But just something that you know exactly what those numbers are going to represent. So if you have to go back to the code book, you can interpret it. This is a continuous variable. That's probably sufficient. If you always want to put more notes, you can, right? That's what the code book is for. But just don't forget that as you work on your next assignment, create a code book, because you're not going to have that many variables. You're going to have probably 3 or 4 variables in there. So it's not going to be too much, but just realize you want to know what order they're in your spreadsheet, because once you get rid of those labels, right, it's just numbers after that. Okay, so always check on your code book, catch it up, right? Especially if you have lots and lots of variables. Really, really smart idea. Okay, so yeah, medicine, we need to get rid of this top row, right? So I'm just going to left click, and then we're just going to delete it. Okay, what's next? Yeah, we got some missing variables here, so we're gonna need to do that. So we need to highlight our data again. Fastest way to do that. Again, don't do the columns, right? Because if you do that, it's going to try to fill in for infinity. We don't got time for that today. Well, actually, we probably do. Today's not Right, okay, because we did a lot of this last week, but we don't want to spend time letting Excel run forever though, right? So, all right, so click on that very first cell, A1, and then you can scroll down to the end, and then if you hold down Shift and click on, in this case, it's like E2671, it'll highlight all of them. Don't have good luck with that. All right, okay. All right, so where am I going from here? So I got it highlighted. What's our command that we're going to use? Control F, yeah, Control F. Will give us our find. Go to your replace tab. We're replacing blank cells, so we're not going to put anything in there, and we're going to replace it with a value that is not in our data set. Usually a negative number works, right? -9, -99, -999, any of those will work. You could even use a value that's positive. You could use like 999. Again, as long as it's not actually in your data set, then or possible within your data set, then it's perfectly fine. You're going to specify what you are using for your missing data anyway in your syntax, but you don't want to replace an actual value in your data set. Okay, so we'll replace all, and it should put -99 in place of all the empty cells. I got 81 replacements. You probably did too. Good. Anything else? It could be any number. Just usually we don't have a whole lot of negatives in our data set, and so a -99 stands out really easy for us to know that, okay, that's just a missing value. It's not an actual number in our data set. Yeah. But we can pick anything. As long as it's not a value in our data set. All right, what's next? Yeah, we save it someplace. Again, M+ does not like to go looking through file folders. You know, I think you have like maybe 6 or 7 file folders that'll look down into. So it's just easiest to put it on the desktop or, you know, in one of your main folders someplace. So file, we're gonna do file save as, browse. I'm just gonna place it on my desktop. I mean, technically you can put it in your downloads too. That would be fine. I'll just put it on my desktop though, just so I can find it easier. You can change the name if you want. I'm just gonna leave it as it is. All right, okay, so what else do we need to do? So we can't just save it as it is now. We gotta do one more thing. What is it? As a whatchamacallit, yes. CSV, comma, separated value. There are several CSVs in here. You want the one that just says comma delimited. All right, looks like I already have one in here. Last year, so I'm just going to replace that one, but yours should be, I think, new. Yes. Yeah, good question. So some things you cannot do in a CSV file. You can't keep highlights. You can't keep equations. So what it's saying is that if you submit it to this, that if you do equations, you're not going to be able to keep those equations with your data. So you'll lose them. But we're not doing that here, so we're perfectly okay. All right, and then once it's there, go ahead and close it out so that it is not open when you use it in M+. Okay. Make sure we're in a good spot before we move forward. Any questions, comments, concerns? Yeah, whenever in doubt, just turn it off, shut it down, reopen it, restart it, whatever it may be. Fine, that'll work. Okay, so all right, so there is that syntax file that you can open up, that Word document that's labeled syntax. And so what I'm gonna do, I'm just gonna copy this over. And again, you don't have to worry about spacing or colons or semicolons or anything like that. It's already in there. So you need to do some edits to it. So help me out. Where do you think we need to make some? Obviously, you need to make some edits to where your file is located. I'm guessing you probably just change your user ID. If it's on the desktop, it'll get you there. Unless you place it someplace else.
What about the color?
All right, so again, if you need to know what your file destination is, you can, I guess just move this. Remember, you can always find your file on your desktop. Right click it and then go to properties, right? And it'll give you the location right here. So just check yours. The only thing that should be different on yours is that it should be your Auburn user ID here instead of my user ID. Otherwise, everything else should be the same. Correct. Yes, because it's not the same one as last week. Oh yeah, good point. Yes. Yes, thank you. Yeah, and then note that the file that we just did does have a different title to it. Has a 4 at the end, so make sure you add a 4 to that. So good catch. Otherwise, you're gonna get the other file from last week. So again, change your user ID here, add a 4. It's not case sensitive, so you can have capitals, lowercases, whatever it may be. But make sure you add a 4 to it right there. Okay, and then also our variables, right? We've added a variable. So in our data set, we have CID, health, weight, active, and now we have calories. Just so you don't get an error saying that there's a variable that's not recognized in the syntax, right? Make sure we add that in there. I think that's it. I don't think there is anything else at this point. Now notice that the variable that we're going to use for this first analysis is just going to be health and weight. So remember, health was self-reported health on a 5-point scale. Again, if you look at our code book, right, self-reported health where 1 is very poor, 5 is excellent, so higher values is better health. We identified our missing values as -99. If you used a different number other than -99, you would put it there in at parentheses. Notice the model here is health on weight. Our outcome variable, or dependent variable, is health. And so in regression, we say health regress onto the predictors. Right? I know sometimes that feels like it's backwards, but it's not. It's always the outcome regressed onto the predictors. And the reason why is because if you don't have predictors, then you start with just your outcome variable, which is health. And then once you add a predictor, now we're regressing what we already have onto those predictors. So I just mentioned that because I know in some of your papers you haven't switched, right? And how you wrote about it, because I think that's how we typically see it. Like this value predicts the outcome, or this variable predicts the outcome. I just realized in regression it's actually the opposite, outcome first. I didn't make any comments on that, but just so that you know. And then notice it's in the model again. So this first one is always going to be your outcome, right? Outcome regressed onto weight. So health regressed onto weight. All right, and then under output, remember from last week, we do want our sample statistics, right, or descriptive statistics for the sample, confidence intervals, and we do want standardized values as well. So those are those 3 commands. And that should be it. So we should be able to run this and it should work just fine. So knock on wood, cross your fingers, whatever you need to do. We'll ask you if you want to save the text file. You can say yes, you can say no. I always say yes and just replace it. It's not really a big deal because you have the syntax. If you need to rerun it, you can do that way, right? As long as you have your syntax saved someplace, it's not a big deal. So, okay, so let's make sure that you're getting some output here. Hopefully you are. If you're getting any errors, let me know. We can work on it. You should get a couple of warnings here. That's perfectly normal, right? If you get more than 2 warnings, then that might be an issue, but a couple warnings are fine. And if you scroll down, you should get values, right? And so it looks good on my end. All right, so everyone get there. Does anyone have anything that did not give them or gave them an error or did not give output? Solving the world problems. You're gonna sit there all day and like all class period and write everything out. Wow. Okay. Just a couple minutes. Good. All right. You got a couple minutes, Susan, because we'll talk about that. Is yours not working? Okay. I would.
I have a lot of technical data. I love that. There's no wrong. I think it's because I'm a big man like that. So I just come so confused. Yeah, I know if I'm not very business. Oh. No. I don't know, maybe we can go out I'm sorry. Nothing happened. What? I haven't started. I've only read a paragraph since the last time. I don't know why, because it's not our papers, like, it's not our final paper. Yeah, it's just a 20 point in addition. No. Girl, yeah, that's why I don't know why you were picking up. This is only 20 points. Or just like a draft, but, no, that's, our edits would be Saturday for the other person. And then our final paper is due the 29th. But he said get as much done as you can. Oh, yeah, because the more you have done, the more you can get feedback on. Yeah. I haven't done it to getting any feedback yet. Yeah. I don't know. Why we can also, and when look, residents of Alabama. We do a discount. Nothing. I haven't tried to upload a new videos yet. That's why I haven't told you that they're done. You're so not. You're so chill about it, and I believe you when it cares, so. Okay, sometimes you guys I want to see what it sounds like for. So as long as you have that, so now I'm going to do paper and then my apartment
Do it when I need to, and what, you know, if I need to.
I'm not doing anything. What is today? So that's not what the one at the bottom. Correct. Not do I have anything? I don't have anything. Marsha's arcade is together, and so if you wanted that, or you can just being out in a lot of our lives, so my mouth. So somebody else has to prove in a bottle. How do you consider these?
All right, I think we're all clear. Let's look at some output. Yes. Not for this, I mean, because this was, I made this last week. I didn't send that out. Yeah, you'll notice that the handout doesn't have calories on there because I printed these out last week. We didn't get to it last week, so, but the output should be the same. It shouldn't matter because we're not using calories in our analysis here, so we should be good. All right, so if you're looking at that output, you're going to see that there is a lot of stuff here. A lot of it you don't particularly need, but if you're doing other types of analyses, you may need some fit indices that are going to be in there as well. It is nice that it gives you the syntax right here, so you know you can always copy and paste it to a Word document or something like that if you like. But your syntax always is at the top of your analysis. So if for whatever reason you're looking at your files and you're like, oh, I don't remember what my analysis was, it's there, it's recorded. So that's nice. The other thing is that this is completely customizable. You can type in here, right? If you want to take notes, whatever it is in your output. If you want to delete stuff, you can, right? So you don't need to do anything else to it. You can actually just work within this text file. So, which is nice. Let's see. So those are obviously some advantages. It gives you some basic analyses like number of groups, number of observations, number of dependent variables, independent variables in your analysis, etc. It'll tell you what you put as your dependent variable. You put health as a dependent variable, or independent variable as weight. So just kind of as a reminder, this is especially useful if you're coming back to it after not looking at it for like a month or something like that. It could be helpful. I would say, always edit out stuff you don't particularly need. That way you don't have to worry about it another time. So anyway, but we won't particularly do that, but if you were to actually save this as your own file, I would remove stuff you don't need and focus on stuff you do need. You do have a covariance, some covariance matrices, some means here, but we're going to have some descriptors that'll do a better job. So I'm not going to worry about that. Here's our covariance matrix, and then here's our correlations. So covariances are unstandardized, correlations are standardized, right? But essentially it's giving us the same type of information. Now, if we look, we can check to see our correlation between the outcome, in this case, health, and our predictor weight. It's a negative 0.152. Obviously, there's no significant values here, but it does just give you a straight correlation. If you had multiple predictors, this is where you want to go just to get kind of a general idea if collinearity is an issue. Right? We only have one predictor here, so this doesn't mean anything in that regard. But if I had 2 or 3 predictors, I could see how they're related to each other here. In case I, might be concerned about collinearity among the predictors. So again, outcome predictors here. So we're not talking about collinearity, but this is where we would look if it was something we wanted to take a look at. Okay, so here is our descriptive statistics. This does take a little bit of understanding, but by looking at it, it's not quite intuitive, but it'll make sense once you get started. So looking at this very first column there, it says variable and then sample size. So it has this forward slash here that's telling you that there's going to be 2 separate rows. So here's my variable, health. Here's my sample size. All right. Okay, so variable weight, number of observations there as well. Okay. So same thing with this next one, right? We have mean and variance. Again, for health, this first one is going to be your mean. The second one is going to be your variance. Now, of course, it gives you the variance, but doesn't give you the standard deviation. So how could we get our standard deviation from that value? Did someone mumble it or? Our relationship between variance and standard deviation is simply close. Square root it, yeah, right. So remember, variance is squared values. So if I square root that value, I'll get the standard deviation. All right, so in this case, 0.776 gives me a standard deviation of 0.88 once I do that square rooting, right? And so because this is, you can edit this if you wanted to, you could put in standard deviation and then 0.88, right? If you wanted to do that, it is one. Yes. Yeah, so just click in there and you can change those values. But if you do it with one, obviously you want to do it with the other ones also. So if we take 1685.755, square root it, you get 41.058. Something along those lines. But anyway, just note that you can edit, respace, whatever you need to do so that it's readable for you. So, but just remember, it's going to come with the variance, right? Obviously, we report standard deviations because we want it in the same metric as the mean. You don't want mean unsquared and then variance squared, that, measure variability squared. That doesn't make any sense, right? So we would want to unsquare that. Yeah, why? I don't know why they did that. I'm not sure where. I don't know. I'm not even gonna guess. So I don't know. Job security. All right, so the next one is skewness. Kurtosis works the same way, right? First one is your skewness value. Second one is your kurtosis value, right? Now they're not given any standard errors for those for you to make your comparison to it. So a skewness table is very helpful here. And so if you look at our files from last week, that there is a skewness table. Did I open it already? Yeah, I opened mine up. This is a Pearson skewness table. This is actually really, really a good table to have, especially if you have large numbers. If you have like thousands of observations, the standard error will often, if you use the standard error, it's often going to show your data skewed just because you have so much statistical power. The Pearson skewness table is not going to be affected by that sample size to the degree that your standard error is. And so very large sample sizes, I would use the Pearson skewness table to determine normality rather than the standard error. I would never use the plus or minus one as a cutoff. Sometimes you'll see that, like if your skewness is less than one, plus or minus one, then it's fine. I use that. Okay, so obviously with smaller sample sizes, you're gonna have a wider range, right? Larger sample sizes, the range of normality is gonna be smaller. What was our first one, like a negative 0.8 something? 824, right? And in this case, we had a lot of, notice that also that as we go up in observations, it starts to diverge, right? So we're really talking about like 0.37, 0.35. So if I'm getting a unit value that's outside of the range, then it's going to be negative 0.8 something, going to be a negative 2. What we consider to be normal is between these two values of plus or minus 0.37. Again, I think you have like 2,500 observations here. So here you need like 0.35, 0.34, 0.35. But either way, it looks like it's going to be a negative distribution for our first variable, which I think was health, right? Yeah. Okay, how about what about our next one? What about our next variable? I got positive 0.84, right, for weight. So it looks like we got one negatively skewed distribution, one positively skewed distribution. All right, but just note that the general rule of thumb of plus minus one, if you hear a lot with SAS and M plus, gives you a really wide range, and so you're saying something is normally distributed when it probably isn't. And so a skewness table is better. The standard error is good as long as you don't have like thousands of observations. Those things are more accurate than just doing a blanket. It's greater than or less than one, right? Or more extreme than plus or minus one, or whatever. Yeah. Correct, yeah. So both of these are going to be more extreme than that, and so it looks like in this case, probably would say that these are non-normal distributions. If we wanted to be thorough here, right, we could take a square health and take the square root of weight to help normalize those distributions. Okay, I'm not going to worry about that. Currently, right now, as we look at this alpha, just realize that it looks like in this case, we're violating our assumption of normality. All right, so this next one, notice you're going to have minimum and then percent and maximum, right? And so this looks kind of confusing here, but our minimum value is 1, maximum is 5, right? And then it's giving you a percentage of 1s and percentages of 5. Does that work okay? So again, it's following the same type of, although this works class. Right, we did our min-max, minimum, we got percentages follows for each one. I got 1.14% of my data set for one, 30.02%. I don't know how useful the percentages are, but it's really like that's what we're saying there. The min-max is going down, up, down. Right, but you can have to that. All right, so this next one is probably the one that's most confusing, and it's starting to take when it gets to confidence intervals as well. So when you look at this, you have your percentile, you have your 20th, your 40th, your 50th, and your 80th percentile. But if you're looking at it, you're pairing 20% with 80%. Using 20, 80 percentile, really you're using this value and this value. And if you're doing 40, 50, there's 40, there's 50. Right? So it's nice fraud. So just keep that in mind, and it'll work that way with confidence intervals as well. So this is what we're used to. And again, it's telling you what's happening in the column, 20, 50, 40, 80. Just remember, if you're reporting percentile, or you're like confidence intervals, right, 20, 80, you go together, 40, 60 would go together. So 20, 80 go this way, 40, 60. And then the median, and I was just. Okay, so just some main things as you're looking at that table, some quirks to be aware of. Yep. Can you just clarify what I know no, I'm just saying confidence intervals are reported the same way, where you have to look and see, okay, the 5% and 95%, where are they in relation to each other? We'll get there in a second, but just notice it's going to be the same pattern, that it's not like both above and below each other or next to each other, but it's going to be diagonal. Yeah, we'll get down there. No, we'll get this confidence interval. Yeah, I think confidence will be, yeah, we'll get down there, but it's going to be like, it's weird, but we'll get down there. It's like spaced out. It makes sense once you look at it. Okay, so I give you name back. They let us know what percentage it was. Right. For health. Correct. I'm sorry, say that again. No. Okay, so percentiles are looking at, yeah, good question. Okay, so when we're talking about percentiles, we're talking about the normal distribution. And your distribution is centered usually at 0. You have negative values, positive values. From here over is 50%. Here over is 50%. Right? This is usually also the mean of your population. Once it's standardized to 0. So the 50th percentile is at the mean. If it's a normal distribution, right? Because that's the center of the distribution. So if I'm saying the 20th percentile is someplace over here. 80th percentile is over here. In other words, 20% of the distribution is from that point over. 80% from that point over. Does that make sense? Okay, so if this is the mean of our particular variable, right, then this value, I think we said was 3, right, is the 20th percentile, is 3, and this value in terms of raw scores would be 5. So it's not saying 20% of the distributions are 3, it's saying 20% of the data is below 3. Okay. 80% is below 5. Yeah, something like that, whatever the mean is, yeah. Again, that was a normal distribution. We don't have a normal distribution here, it's actually skewed, but generally, yeah, we would expect the mean to be between those two values. If it's a perfectly normal distribution, it'd be right in the center between the two. But here it's going to be, weighted slightly to one side. Okay, if you want to know percentile. There you go. Yeah. You wouldn't necessarily report it. I mean, you could, instead of variability, you talk about percentiles. I don't think that's very common, but just note that when you're looking at your output, how you read it will depend on the column, right? And just note that 20, 80 are paired together, 40, 60 are paired together, but notice there's like kind of a crisscross going on here. Okay. All right, so that's it. Many things that you would want to know in here. Obviously, you want to know your sample size. You want to know your mean and standard deviation. You want to look at your skewness statistic, compare it to that table, determine if you have a normal distribution or a skewed distribution. And obviously your median would be useful, min-max is useful also. So if you had skewed, maybe we'll just cover this, I know you know this already, but if the health is skewed, if a negative skew, then what's my best measure of central tendency? Median, right? Best measure of variability is the range, right? And so you can report min-max or you can say a range of 4. Right, either way. But anyway, everything you need here to report is here. Just remember, got to change that variance to standard deviation, right? And then, note how your skewness statistic and everything else is aligned in here. Okay, so let's go to our model fit information here. You notice you're going to get all the log likelihood and chi-squared tests for fit and root mean squared errors and fit indices as well. That's not going to matter with a simple linear regression or a multiple regression. This will matter if you have like a path analysis or confirmatory factor analysis, especially structural equation modeling. Like all those things would be things that we would care about the fit indices. So for this analysis and what we do in this class, we're not going to be worried about this. So if you wanted to delete it, you could. It wouldn't really make much of a difference. All right, but when we get down to the model results, that's where we really want to start looking at our data because it's going to be our regression output. Again, it does take a little bit of looking at to get used to. So if you're looking at it again, we have health regressed onto weight. Health is the outcome, weight is the predictor. The estimate in this case is going to be your coefficient. So notice here they're called estimates, but that's your coefficient. That looks weird. Is that right? Okay. I don't know. All right, and so in this case, we have a slope coefficient of negative 0.003. Label that slope. Your intercept down here is your constant. Your residual variance here for health is going to be your mean squared error. We haven't talked about this, but if you take the mean squared error and you take the square root of that value, you get the standard error of the estimate. I'll put SEE equals mean squared error to the 0.5 power, which is a square root. So I take 0.758, square root it. I'm going to get 0.87 for the standard error of the estimate. Make sure I'm not forgetting anything. All right. So this first set of data is your unstandardized regression equation results. Notice you get a standard error for your coefficient. So notice it's not 0, right? It's actually less than 0.001, right? So nothing can ever be 0. Same thing here. But we've talked about this before. Don't report zeros. It's less than 0.001. Okay, but you have this estimate divided by the standard error. What do you think that value is? Your estimate, your coefficient, divided by the standard error. So what is this value going to be in this column? Coefficient divided by the standard error. That's going to give you go. That is your key statistic. Oh, because they think you know that if you take the coefficient divided by standard error, then that's just your key statistic. That's your key statistic. Come on, everyone knows that. Come on. Just walk down the street, ask someone how do you get the key statistic, and they're like, like coefficient divided by the standard error. I'm joking. Yeah, I don't know, right? It would be easier if they just labeled it, right? Okay, we good so far? So it comes as a regression equation here. All right, so if we're looking at weight, does weight predict self-reported health? Yeah, it looks like it does, right? Our p-value here, again, detailed p-value is less than 0.05. It's actually less than 0.001. So it does look like weight of an individual predicts their self-reported health. But just know it looks a lot different than what you're used to in the SPSS output. But all the information is there. You may have to do a little bit of manipulation to get it, but it's all there. Okay, so again, if we were to write out this regression equation, you say y equals 4.565 minus 0.003 times x plus last minus your standard error of the estimate of 0.87. That is your regression equation. Interpretation works the same way as all semester, right? Slope is just every 1 unit increase in weight results in a negative 0.003 self-reported health. That value makes sense because, again, weight is very wide range of values for weight, right? Whereas health is only a 1 to 5 scale. So you got to increase weight quite a bit to really have an impact on that health. We would expect it to be very small. 1 pound increase. We would expect that to be a very small value. Okay, we okay so far? No? Some of you said yes, some of you said no. Anything I need to be more clear on? of the different coefficients? Yeah, so in this case, our slope, again, rise over run, so every 1 unit or 1 pound increase in weight, because we measured in pounds, 1 pound increase in weight is resulting in a decrease in self-reported health of 0.003. Okay, and then if we go to our intercept, again, that's the constant. So when weight is 0, this is the average self-reported health. Right. Obviously, that doesn't make sense because weight isn't going to be 0. Right. But that's where that crosses, where the line crosses the y-axis, is at 4.565. Okay, and then standard error of the estimate. So for any one prediction using this equation, right, we would expect it to be off, or 68% chance that that prediction would be off by 0.87 self-reported health units, right? Because it's in terms of your outcome. All that's the same as we've done this entire semester and last semester. Okay, let's go to our standardized model results. There's several different standardized models results. The only one that you are concerned with is going to be this SPDXY. This is basically standardized on both your outcome and your predictors. And so your standardized slope coefficient is this value right here, negative 0.152. Yeah, same page as everyone, right below, second half of that page, bottom half. Yep.
These are on the flat side.
Correct.
In this case, it is
Unstandardized.
right. But you don't report that not right.
Probably, yeah. Sometimes people like to put their betas in there, so not just the unstandardized coefficients, but the standardized coefficients.
If I'm doing the next comparison, I will simple result. Every time I will simple result.
You would, yeah. You can still report your betas if you wanted to, but the unstandardized, that'd be there. Yeah. So again, all we're really saying is, so remember that these are representing your B values for your coefficients. Your standardized value here is going to be beta. And not surprising, right, that this beta value here is the same as your correlation up here. Negative 0.152. So remember that correlations are standardized. Beta is your standardized value. In simple linear regression, your beta value is the same as your correlation. Wow. Oh, okay. Oh, I thought Jamie said wow.
I did say
oh, you did say wow? Oh, that's what I thought. I'm like, did you do that from? All right. Memory decay is a real thing. I understand. Yeah. Right. Yes. Beta is the Greek letter. That one. Yep.
Not B.
Not B. Right. Yeah. I mean.
How come there's like multiple
Here? Or like intercept? No, yeah, so yeah, then you have your standardized on the outcome. And then standardized with latent variables. You don't need to know those. You don't care about those. So you could delete those if you wanted to. The one that you want is the standardized on X and Y. So again, on your predictors, on your outcome, on both of them, that's the one you want. Yeah. So even here, like the only thing you really need is this beta value for your slope. And that's all you really need here. For your slope, for the weight in this case. One you want. So again, simple linear regression, your beta value is just the same thing as your correlation. In multiple regression, that's not the case because your predictors share variance with each other, and so the values should change. If your predictors were completely uncorrelated with each other, then yes, they would match the correlation coefficient. Only because they share variation that those values change. Okay, let's see. Scroll down, I guess. All right, so here you're going to find your effect size, R squared. So here's your estimate, it's 0.023. Notice that it can also, you've seen this before, R squared can be also used as a hypothesis test, and that's what you see here. Again, you know, your test statistic and then your p-value associated with it. So this is at the model level. So is the R squared significant at the model level? And the answer is yes, which makes sense here because the individual predictor was also significant. So you'd expect the model to be significant. But just note for the overall model, R squared value for the overall model, and is that overall model significant? Overall model. Here we only have one predictor, so it's going to match what we did earlier. Okay, so we get some interpretation here. R squared value, that's going to represent what? How can we talk about it? Right, explained by this model, but we can be more specific. 2.3% of the variance in health or outcome variable can be explained by the model here, but model only consists of one predictor, right? So it can be explained by weight. Yeah. 2.2, yep. Yep. Yeah, turn it. Oh, did you? I'm sorry. Yeah, 2.3. Move it over 2 places. And then size of the effect in this case would be size of the effect. Small, yes. Small, right? Continuous variable. So remember, small is 0.01, moderate is 0.09, large is 0.25. It's going to be closer to small than it's going to be to moderate or to a medium effect size. I will not. But I like the word. I like the word. All right. Okay, and if our predictor was categorical, remember that those coefficients would be different, right? 0.01, 0.06, 0.14. Again, because you're restricting your range, right? When you use categorical data. So that's going to retract the R squared values as well. All right, we're almost at the break here. I know you guys are barely hanging on there. Let's get this last part, and then we'll get to a break, and then we'll do a multiple regression. Okay, so here's our confidence intervals, right? And I mentioned before that this is going to be kind of messy too, but it makes sense, right? You just have to look at it cross-eyed. No, I'm just kidding. All right. Okay, so again, it's going to work exactly the same way. You're going to have your predictor, your constant, your residual against here. So notice that my estimate is right in the middle, right? The slope coefficient was negative 0.003. Okay, so if I'm looking at a 90% confidence interval, so 90% would be 5% on each side, right? So 90% would be from negative 0.004 to negative 0.003. 95% confidence interval, negative 0.004 to negative 0.002. 99% confidence interval, negative 0.004 to negative 0.002. That makes sense? Starting in the center, 90% are these two, 95% are these two, 99% are these two. So again, our best guess for the slope between weight and health is negative 0.003. We can say that there is a 95% chance that the actual population slope falls somewhere between negative 0.004 and What's happening with it? What actually is happening now? Okay, anyway. Our best guess for the slope, right, for weight, for distance out is -0.003, that's just based on our data, right? But our sample is not what it's going to be in the population. And so this gives us a range of where we expect extreme population slope to fall. And on this particular case, there's a 95% chance, again, using 375, 95% chance that the true population slope will be between -0.004 and -0.0. We wanted to say 90%, right, and 90% chance, 99% chance. But so start at the center and then you work the way out.
You know, there's like a thing where the government can do one at the time, or the government can do one at the time.
Here would be 0, and this doesn't mean it's a problem. So again, confidence intervals are not hypothesis tests. We kind of use them as them because it works most of the time, not all the time. Right? Particularly if you have one tail test, don't use your confidence intervals as indicators of statistical significance. But generally, if you have two-tailed tests, it works the same way. That if your confidence interval contains 0, then it should be non-significant. If it doesn't contain 0, then your hypothesis test should be significant. And that only works with two-tailed tests, but that's not the purpose of a confidence interval. Your hypothesis test is for rejecting and self-rejecting all. The confidence interval is to try to identify where the population parameter is. That's its goal. It's not to do statistical hypothesis testing. It just happens to overlap if you have a two-tailed test. Okay, so same thing below, you get some more confidence intervals of your standardized beta coefficient, right? Works exactly the same way, just realize it's your beta now. So it's centered at your beta, -0.152. Again, 95% chance that the true standardized slope in the population is between -0.189 and -0.114. But it works the same way, just now we're talking about standardized values. In other words, Z-scores. It works the same way. And then you don't need to worry about standardization just on Y or standardization on latent variables. And then scroll down to the very end, and then here you're going to see there's a telephone number in case you need to contact someone. I don't know, if people still use faxes? Like, do those exist anymore, fax machines? Do they really? Haven't seen them in a long, long time. All right. There's also the website as well as an email address here too. I have had students call and they said they're really responsive. Like they respond quickly. As they should. All right, so that is going through one set of output. Let's take a break here. Let's come back at 12:40. That gives you about 12 minutes. And then we'll look at a multiple regression. It should go pretty quickly. But I'll have you working through it since now that you've seen it. Okay, all right, 12:40. We'll do moderation. Probably not. I don't think I'll have time for it. We could. Not to say we can't. But definitely moderate. Yeah, I'm thinking maybe we'll, I don't know. We'll see where we're at. We'll see where we're at.
Just one day possible. Can make it together anytime.
Yeah, if that's time, we might do that.
Just one like very
I didn't plan on it, but it's not hard to do.
For each our number of observations is more than 100, and the lies between 0.27 or 42.27, it would be normal distribution, and if it carve this point, then we consider this as either negative Q or positive. Am I right? And in our national report median sensitivity,
can report if it's a normal distribution number, if it's a skewed distribution, and you can.
Okay, so we have to report this percentage?
Good, yeah. But you report the median and the range, or if you want to do percentile, that'd be fine. Oh, yeah.
Okay, so we have to start with
Sorry, say that again. Yeah. For everything.
So at this target, I'm at this comfort in my recommendation, and the next target, I do comfort. And
You'll have to submit it
by this second.
right, yeah. So yeah, I'll be there next Friday. I'll be there this Friday, I'll be there next Friday, yeah. That would work. Yeah.
Will be on office next Friday?
I'll be in office next Friday. Yeah, you're welcome.
So using this paper, which is, I will address many of the comments, many of the minutes, I will work 90%. Because I have many things to do. No problem with this, but I will other production. I will my best. But yeah, you know, I compared it with my colleagues, they have to take a step. I think he didn't like, he really told me the first time that just in one paper, in one paper.
You only have one day.
Just I need to do that.
If you give me a sec, is this time at 2 and 3? Because remember, 2 and 3 are the same, except 3 has multicolor in there.
Correct.
Right.
So what about the second one?
That's the back.
I don't know.
Oh,
And, but,
I'll take a look. Send me an email right now, so I can look at when I get back to my office.
and you know, mediation, very material, very important. So then I include mediation for my answer. This is significant or not?
So it should be significant
And this
by itself,
yes.
and then once you have your mediator, then it should be non-significant. Correct.
What is it's still significant but not
But it reduces, you should have partial.
so if this is not significant at the very beginning. So by run this mediation
It wouldn't make sense to do so.
again, it might
I mean, I guess there are some arguments. You have to look up the papers. I haven't looked at them. There are some arguments that say you don't have to necessarily meet all of the qualifications for mediation, mediation. I haven't read them. If this one is, I've heard some like if this one isn't or this one isn't, then you can still do it. I haven't heard, off the top of my head, I haven't heard of one saying like if your past fee is non-significant, still do a mediation. I don't know.
So what
If you can find someone who says that and it's reputable, then why not?
this significant is not significant.
Yeah, I think there's some articles out there that say
It
that
means,
you can still do it.
and this one I just get, maybe I'm not, I know, but I think that I know. This significant, from a mediation.
Yeah, traditionally you would have no mediation, but it's all based on the indirect effect. So the combination of A to B may be significant, even if B is not significant. So that's the argument. The argument is, well, even if one of these is not significant, if the indirect effect going through that mediator is significant, the combination of the two, then you still have mediation. Again, that's not the traditional approach, but that is a more contemporary within the last.
Is it correct? So you said when I entered this model, you could not be significant.
It could reduce or not be significant.
Okay. But what I remember from it, but at the end of the table, here we have the P volume, and we still can see if it's significant or not for this side. We don't have to set the previous side. We have to set the other side. I mean,
Yeah, I mean, you have to check all your paths.
okay. But I see that.
But this is a mediation though, right? So mediation, you're gonna have multiple regressions. You have one here, you have one here, you have one there. And you have three regressions. And this is only one.
No, I mean,
Yeah.
I'm not telling you about.
Okay. Yeah, so you'd have three
But the
separate smaller
output give us,
results.
output give us whether it's significant or not. Yeah, so we don't have to say, but we see that the output give us, then the indirect coefficient as well, and the P value as well.
Yeah, if you put in the syntax correctly. Now, if you're gonna do it the long way, then you have to do a social test. You have to do that.
There's no process, right?
That's just a process.
I mean, this one.
But it's supposed to be on there because we used it last semester, so it should be on there. Unless they re-imaged, in that case, they have to add it again. Yeah, it should be right underneath, under regression, right underneath your curve estimate. Yeah, I have it here. It should be right there. So regression, and then right there is where it should be. Yeah, I don't see it on here. Computer doesn't have it. If you go to that computer, it should be, or that computer, it should be there. Yeah. You're welcome.
I'm sorry, I think I submitted it this morning. I couldn't send it on Monday. I haven't.
Okay. Yeah, I haven't got it. If you sent it this morning, I haven't got it yet. So I'll just try to get you and get back to you by next Wednesday.
So yeah.
I think he's smart, Kurt Bundy. Yeah, he's so smart. He doesn't even know it. Yeah. I think he knows.
I could get water before it started, and then so like they're almost like licking ice cubes.
So funny. That's hilarious.
That were dairy free? There's no snacks that are dairy free in it?
Well, there was sports teams, but I have a good time too.
That would be great. Is it because they have like marshmallows or something? Like where's the milk from? Are they? I have no idea.
Yeah, but what's not is like chocolate and stuff,
Right.
every, you know when those like bars that have like the fish filling sometimes, or like, those are really not really sweet for some reason. But I do have a good bars, so I
Like like the bread, like
yeah, probably.
like just like
I don't know, I don't know what's in it, but
Can we make a cake and usually add milk, right?
yeah. Or they have a piece of fun. Yeah. You said that we have the put in the syntax, the interpretation of everything is the same as the regular interpretation.
Yeah, it's gonna look a lot like your last time. It's gonna look a lot like assignment 1. Except you'll do a moderate and do an interactive. Yeah. You're welcome.
How bad was my assignment 4?
That's good.
Okay.
All of them are pretty good. I would say from the ones that.
That's how I feel about
Yeah, no. I mean, at this point, you've seen enough drafts and edits and stuff that 4 and 5 usually are pretty good. All right. What's up?
Hi. You like the break? Or chicken break?
Oh, looks like it's 12:40 already. Look at you guys. 12:41. Squeeze an extra minute out of it. You got everything cool? All right, let's get back into it. Okay, so went through an example of just a simple linear regression from start to finish and plus. You know, everything is there. Again, you have to do a few cleanup things, like I said, like doing the standard deviation, doing the standard error of the estimate, and the majority of what the output is there is okay, so let's do the same thing. Let's add a variable, or let's add 2 variables. Let's just show a multiple regression with all 3 of our predictors. So we'll do what, the activity, weight, and then calories. Look at the output, and then you walk into the output. Tell me what you see, and see how it's different. It's not gonna be much different, but I mean, if you can do a simple linear regression, the multiple regression doesn't look very, very different from it. All right, so go to your syntax. If you're looking at your syntax, obviously your file is not going to change. That's all going to still be there. Your names of your variables aren't going to change. Yes. I mean, you could pull up the syntax document. Oh, you mean it just doesn't show on there? I think if you like minimize. Yeah, if you minimize your screen, it can show up. Okay, so what do you think will change in our syntax? Right, we're going to add active activity level and then calories. Again, if we look at our code book, at self-reported activity level was dichotomous. Either they said, yes, I'm active, or no, I am not. Here it is. And then calories, again, number of calories in a day in terms of 100. All right, so how's that going to impact our syntax? What do you think? So we do need to change to our model, right? So what do we need to change here? multiple regression. Active and then calories, right? So go in the order of your variables. So the active, make sure there's a space between them, and calories. But just note that all your predictors are going to be on the right side of that model, because again, we're taking our outcome variable, regressing it onto our multiple predictors with active and then calories. All right, do make sure that your spelling is the same as the spelling up here under the variable name. Right, they have to be the same, otherwise it's not going to read it. Easiest way to do it is if you just highlight and copy and paste it, right? Then there's no doubt. Yeah. Yep. Mm-hmm. It is. Yeah. Yeah, it is possible to do that too. Yeah. Yeah, so we got the model, but then Samia is saying that we got to also talk about our used variables up here.
Oh, yeah.
Right. So we're telling it which variables, because remember all your columns of data have to be accounted for under names here, but you don't have to use them all. Because here we do want to use all of our variables, not CID, of course, but the other ones. So make sure there's spaces, and then again, if you copy and paste it, then you don't have to worry about accidentally misspelling something or switching two letters, right? And then giving you an error, and then you spending 30 minutes trying to figure out where that error is. I don't know if that's necessarily a requirement. I do just because, you know, I don't want it to kick back an error. But if you want to test it, switch it right now and just run it really quick and see what happens. I mean, that would answer our question for us. But I want to say it matters, the order matters, but it may not. Nope, yeah, good question. So analysis, nothing's going to change there. Still just the general analysis, estimate or still maximum likelihood. So we don't need to change any of that. Did that work, Austin? They like it? Yeah, I liked it. It was fine. Yeah, so yeah, it doesn't necessarily have to be in the same order. It's not, it looks like. All right, but if you're just copying and pasting it, then it will be, right? But it doesn't sound like it necessarily has to be in the same order. We all learned something new today, including myself. All right, that's it, right? So that's all we really need to do is just change our use variables, change our model, and now it should run as a multiple regression. We click run. It should be good. Yeah, mine turned out good. Did everyone turned out all right? Make sure you have all your semicolons and stuff. Make sure there's spaces between your variables. I did not print this one out. Oh no, you can edit in your window though and save it if you want. Make you work a little bit from time to time. Okay, all right. So I think anyone not there? Yeah, a couple minutes to find it. You there? Okay, so let's take a look at it, right? So again, some basic stuff up front. We do have our covariance and correlation matrices. What are we looking for here? Yeah, we're looking for collinearity, again, among the predictors. Does it look like any concerns here? No, it doesn't look like it here. Everything is pretty small correlations. Again, we're not interested in the correlations for health on our predictors. We're interested in our predictors to each other, right, which is going to be this 0.062, this negative 0.03, and this negative 0.015. None of those are near 0.4. Does not look like collinearity is probably going to be an issue here. By just looking at the correlations anyway, right? There's obviously other metrics. All right, and so let's take a look at our different variables here. We already know about health and weight. We already talked about those two. So essentially what we're looking for here is which measures of central tendency and variability would be best to report. Like I said, we already got health and weight. Let's look at active and calories. So what are you seeing here? Yeah, so again, if we're looking at our table, it is based off of our sample size, right? So somewhere around plus or minus 0.37 or 0.35, something like that. And for active, what do we see here? 0.25 or 2.251 seems to fall within that range, so we would conclude normal distribution, which means our best measure of central tendency and variability is mean and standard deviation, but we don't have standard deviation here, right? So square root the variance. .496 would be the standard deviation. All right, what about calories? Oh, we'll go back. Okay, we're gonna go back to active in a second, but what about calories? So yeah, we had negative 0.043, right? Which means what? So I mean, it has a negative value to it, but the question is that enough for us to say it's non-normal? No, right? It's still the same cutoff, right? Still plus or minus 0.37 or 0.35, right? So this looks normal still, right? Okay, we do need to go back and talk about active again. I kind of messed that one up, so but we'll come back to it in a second. So 0.138 to square root is going to give us 2.034. That's going to be our standard deviation. Okay, so I had a mental lapse there for a second when it came to our variable active. How was active measured?
Oh.
Dichotomous. Does it make sense that we have a standard deviation or a mean if it's dichotomous? If it's a nominal variable, means and standard deviation don't really mean anything, right? So that's actually not very useful to us in this case. So that was my mistake. I apologize. Remember, how you measure matters, and so if it's active or not active, a mean of 0.438 doesn't really tell us anything because that's not even a possibility when it comes to like what is that partially active, but no one's partially active is everything they already aren't, right? Now, if it's continuous, then the mean makes sense if it's measured continuously, but it wasn't here. So if we're not using the mean or standard deviation, then what is going to be our reporting when it comes to our descriptive statistics? So yeah, the mode, but yeah, so the mode is correct, right? That's our best measure of central tendency is the mode. Of course, we would use the range or minimum max as well. But just realize that in this case, when we talk about the mode, what we're really saying is how many are not active, how many are active, and what are the percentages, right? And so if it's dichotomous, then you don't necessarily need to report all of it. You report one and the other one's inferred, right? If it's multiple categories, then the number of observations and percent for all of them would be important. This is dichotomous, right? And we can see here, right? We have zeros, we have ones, we have 56.22% of the data as zeros, 43.78% as ones. All right, if you want to turn that into numbers as sample sizes, just take your total count 2595. All right, multiply it by your 0.5632, and it looks like it's about 1459, like 1,459. So you can still get ends there by just using your percentages, right? But just note that in this case, we would just report what percentage is active, what percentage is not active. Okay, so again, importance of your code book. Again, just look, how are my data? It's a nominal data, then mean standard deviations, medians, they don't really mean a whole lot, right? They don't represent your data well. Okay. Let's see. I think we're good there. All right. So again, we don't need to worry about fit indices here for a multiple regression. Let's go down to our model results. Start doing some interpretation there. So what are some things that we need to know when looking at this? Yeah, we can jump there, right? Again, we'll talk about labels here in a second. So what do we see when it comes to our predictors? Which ones seem to predict self-reported health and which ones don't? Yeah, weight and active look like they're significant. Calories does not, right? So the reported calories consumed a day doesn't seem to be predictive of their self-reported health. But whether they're active or not does, and looks like weight does. I'm sorry, Samir, what are you gonna say? Say that again. Yes. Right. Yeah, so let's interpret that. So one's positive, one negative. This value right here, because this is a categorical nominal variable, how would we interpret this 0.306? Difference in terms of like the averages, right? The mean. All right, so we're saying in this case, whatever is coded as 1 is 0.306 health units higher on average, right? It's just a change from 0 to 1, not active to active, tells us in this case health is increasing, or self-reported health is increasing by 0.006. So it's the mean difference between the two. Okay, so just remember that it wouldn't say for every one increase, so there is only one increase. You only go from 0 to 1, right? So it's just the difference in the mean. So all you really need to say here is that, you know, those who report as being active, their health is 0.306. The average for health is 0.306 higher than those who are not active. Those who are active, the mean health is 0.306 higher than those who are not active. That would work, I think. Okay, your estimate divided by your standard error here is what? Your T statistic, that's right. So again, you need to report your T statistic, you're gonna find it right there. This is your unstandardized coefficient, so this is going to be your B value. Yeah, I'll get down there in a second. So what else do we need here? So we do have, let's just do this really quick. Let's put our regression equation. So y in this case equals 4.492 minus 0.004 times x1. I guess we could put like x parentheses weight, right? Plus 0.306 x, where it is now active, minus 0.001 x calories, and then what? All right, now we're gonna get that standard error of the estimate. Yeah, square root are residual variances, right? So variances is mean squared. So that's your mean squared error. So to get that standard error estimate, we take the square root of that value. $859.860. I'm rounding to, if I go to 3 places, it still rounds up to 8.86. Yeah. Okay. That's your standard. That's your mean squared error. So take the square root of that. Yeah, your variances is just the mean for the average square deviations of what your variance is. So that's mean squared. So this is MSE or MSR for if you say MSE, if we call it error in ANOVA, and regression we call it MSR, mean squared residual, but it means the same thing. It's exactly the same thing. Yeah. Square root of this value. The standard error of the estimate. Square root, the mean squared error gives you this 0.86, which is your standard error of the estimate. But good? Good? Okay, so just remember, you do have that standard error of the estimate, you just make sure you know where you find it, and make sure you take that square root. Okay, so if we go to our standardized equation, so again, we're looking for the STD-YX, standardized on Y and X outcome and predictors. All right, what are we looking for here? Well, I think that is right here, 0.1. Yeah, you don't really need to worry about too much else here, right? Notice that when it comes to your p-values, they're redundant with what's up here. They should be because it's just the same thing standardized, right? And so this is really all we're interested in are these 3 values right here. What is nice if they're standardized, you can get the relative impact of each of them. So it looks like comparatively, whether someone is active or not, looks like it might have a slightly higher relationship with health than weight does, right? And so you cannot get that from the unstandardized because they're on different units of measurement. But here they're all in terms of Z-scores, they're all standardized, and so you can directly compare those estimates to see, well, which one is having a higher impact on my outcome. Active is that significantly different? Probably not, but it is slightly higher. Okay, and really that's the only, I think is the main advantage for your standardized coefficients is that you can compare relatively across your predictors when it comes to your outcome. Otherwise, the unstandardized, it makes more sense because we don't usually talk in terms of Z-scores. Right? So when we're interpreting our coefficients, unstandardized is usually best unless you're making relative comparisons across your predictors. And then data makes sense. All right, and that's really all you need here. Help me out with R squared. Yeah, 5.3% of the variation in health can be accounted for by, activity level or activeness, weight, whatever the last one was, calories. Small, moderate, or large effect. This one's kind of tricky. Maybe it's not tricky. It's not. I mean, it's not tricky. It works out no matter what you do here. What do you think? So again, you know, if we had all categorical predictors, it would definitely be medium, right? But we do have a couple of continuous predictors. So even if we're being conservative with our continuous predictors, 0.09 would be moderate. So if you're looking for halfway between 0.01 and 0.09, you would get what? 0.45 or 0.045, right? So this would still be moderate. It's still moderate no matter which way you look at it. So yeah, so a moderate effect. Again, but that's not any one predictor, it's a combination of all of them. Just the overall model. Okay, that look good so far? On the same page? All right, let's look at some confidence intervals. So it's going to be our interpretation for our confidence interval for activity or active. So this is an output that we got. Yeah, I'd probably say interpret them, right? So that would include giving them, but yeah, you can't interpret it without knowing what they are. What's that? Yeah. No, it's in the back of my mind now. Randomly, it's gonna come up with my random selection of All right, so let's talk about what is our interpretation for the 95% confidence interval for our variable active. But is it slope? Okay, those are the values, 0.39 and then 372. Very good. Yeah, I think, yeah, so you're getting closer to it, probably want to rearrange that just a little bit, but yes, I think you're almost there. So 95% chance. That's a population what? Not slope. Mean, right? Population mean. That's okay. That's why we're going over it. All right, for those who are active, have higher health scores between 0.239 and 0.372. I guess health ratings, I guess, higher than non-actives, right? Yeah, you can. Yeah, you should. You should. I'm not usually too strict about that, but yeah, you should. You don't have to necessarily list them all out. We can say when the other predictors in the model. That's fine. Okay. So just note that in this case, because it's nominal, right? We're talking about a mean difference that you have to talk about in terms of mean, not in terms of scale. Not on the continuum, categorical. Yep. Okay. And then weight and calories, that would all be the same as before. So, because those are continuous variables. All right. So let's see. So let's go back to our model. Oh yeah, right here. All right, so we have weight, active, and calories on our multiple regression predicting health. Is this the best model? Yeah, why not? Why would this not be the best model? Calories is not significant, right? And so if we keep this in the model, we are essentially putting error variation in our model. Because whatever we see here, whatever variation they share, we're saying is because of chance and chance alone, right? And so by keeping it in here, we are theoretically increasing the error of our model. And so it would make sense to back out calories, right? And have a model that only has our two significant predictors, weight and active. But remember that calories is impacting those B coefficients, right? The fact that calories is in there and it's not predictive is impacting the coefficients or the estimates of our parameters. And so we don't want it to do that, right? Now, if they were all perfectly uncorrelated with each other, then it wouldn't matter if it's in there or not, right? Because those coefficients wouldn't change. But they do share some variation, and so those coefficients are being impacted by our non-significant predictors. All right, so for kicks and giggles, let's back it out and refit it, and then that would give us better estimates for our slope, as well as, whether or not our variables are predicted. Okay, so that means you have to remove it from the model, as well as our use variables command. Once you do that, again, don't delete your semicolon. Once you do that, hit run. Right, and you should get your output.
Yeah, just because of the thing, just because we think it's not significant.
It wasn't significant, so there's no reason to keep it involved. Because again, right, if you just leave it in there, that chance variation it has with the other predictors as well as the outcome is impacting. If it's not significant, then it's not predictive. So it shouldn't be in our equation.
Okay, but if I'm making like a piece of predictor, right? Not significant. So if I put it out, I'm controlling for it or not?
No, you're not controlling for it, but if it's not related to your outcome, there's nothing to control. Right? You're saying it doesn't matter. It doesn't matter if it's not predictive, then it doesn't matter.
So you delete it, and now you will say that this model is better, I guess.
It should be left error.
Yes, but
Yeah.
Maybe I know something from some class. It's saying you have to compare the chi-square. So the chi-square value. Correct?
If you're doing like SEM or path analysis, yeah.
So I have two models.
Because those are going to be like your fitness piece. Yeah, and you compare across your models and see if one is better fit than another. Yeah, that would make sense. Yeah, but even there, if you have a predictor that's not significant, it has no business being in the model. If you include it, let's say you include it and your fit's better, you include a non-significant predictor and your fit's better. No, what it's saying is that better fit is because of chance, not because there's actually something going on there. So basically, you're capitalizing on chance. Yeah.
But in the paper, it's like multiple predictor. They also see
They do. I see it in papers all the time.
five of them, they have what they do.
Yeah, I mean, I see it all the time, but they shouldn't do it. So. Okay, so I know you're getting a little bit antsy. So, all right, so hopefully that ran for you. Hopefully you didn't have any errors. So again, not much is going to change here, but just know that, this would be a better model. None of your descriptors are going to change here, but when it gets down to your model down here, right, your estimates might change a little. Here, the correlations are actually pretty low, so I don't think it's going to change much. I don't remember what they were before. It's still negative 0.003, right? Was this value the same or was it different? It might be slightly different. We got rid of it? Well, anyway, there wasn't a high correlation to begin with, but what happens is that it does impact our coefficients. The more correlation our predictors share, the more our coefficients are going to be unstable, right? And then remember also your standard errors will tend to inflate as well, just because they're sharing variation. So if I can get rid of those non-significant predictors, I'm going to be more confident about these estimates than I would if I had a non-significant predictor in there. Because what we're saying is that that variation that it does share is because of chance and nothing else. If it's because of chance, then that's error. Right, let's get rid of it. Let's move it. Make our model more parsimonious, right? Make it more efficient. Get rid of that dead weight, and then we'll have more confidence in our estimate. Okay. All right. That's all I got for you guys today. That's it. We will, but we don't have time to finish it, and so I'll save it for next week. I was planning to save it for next week anyway. It's not due next week. Yep. Okay. Oh yeah, thank you. Yes, forgot. Thank you. Yes, and then edit for assignment 4 and top those out for you. All right, so if you have questions, let me know. We have some time now. Also, I'll still have my office hour obviously at 2 o'clock. So feel free to message me about that. And then I think that's it. So obviously I'll be there on Friday too. Nice paper? No,
Oh, I didn't know. I'm listening to
So if I was to look at that, just like scrolling through a paper, and I'm like, that doesn't add to 100%. I'd be like wondering, like, where's everyone else? So he said in the paper part, but just not in the table. You can put it like a note, or you can redo the percentages, so does that do 100%, right? So you can do any of those things. Yeah, but you report your missing data later. Like you can report it in like your deficit section and think of what was analyzed, because the missing data wasn't analyzed. Right? So what was analyzed, how much? Does that make sense? Oh my goodness, okay.
Yeah,
because it's like it's not like you're going to count if you're looking at your mean percentage, you're not impacting the percentage, right? Right? So it's like this is the
On your categories that add, oh, like, when we're not in that.
Well, I mean, you add them up and there's 29 out of, you got 50, 29 out of 50. I don't have 42%. Yeah, I have some right now. You can look at that now. Yeah. Go ahead.
Don't forget my assignment one, okay?
You can send me an email? Send me an email right now.
Remind you.
Okay.
Remind
Perfect. Yeah, I'll look for it. I'll see. And if you, let me look for it. If I don't find it, then I'll ask you to reach out. I'm pretty sure I have it. I'm pretty sure I edited it. I recall editing it, and so I don't know why I didn't take the copy. So
maybe I was okay. I don't know, maybe. I don't know.
maybe. That could be it. It should be on my shelf.
Maybe I was okay. I don't know.
I don't know. Yeah. Okay. Yeah. I mean, yeah. If you can't get it, then I'll just post it.
Oh, yeah.
Yep.
I thought you said you could use the outfit to become your time together. You did some really recent research on my serious person. I have the other half now again. The one that I use, which one, like if you have all those, which one to sound like. Yeah, I see. Oh, yeah. Well, yeah. So I use the outfit and I was like, but after doesn't make it the next model. I have to instead of the outfit. That's what he told me. So like, where's the outfit? So the art where you have to think about in terms of none of your models are right. Why would you do it models that
no, my other Twitter, because every time you add a position, it's going to start quick. And then it's going to, if I put 1,000 on with it, they won't be. So, on I should but you definitely probably not. No, it's not really. But you need to report something for the city. But really thinking about, because you're gonna see that in paper a lot, with models and like really nice and certain movies. How is that impacting? Variables that really don't have any relationship. But yeah, well.
Yeah, who's your partner? Yeah. Okay, so, yeah, you already sent me the full ID this one here. No, as soon as you're done writing it, and you send it to Thursday, Matt, you also send it to Beth. Yeah, and then she'll. You can do this on the day of the second, am I right? Yeah. No, you can do it before. You can send it to her now if you're done with it. Yeah. That's not, it's not required until you submit it for that. And then you have to do that computer do that. Yeah. On the different. Yeah, that's okay. Yeah. Thank you. No problem. You already sent me. That's up to you now. I'm done my thought this stuff is right. Yeah, no, I think it's probably done early.
Yeah. One time.
model three is not selected because of the interest in state of the standard.
No, this is incorrect. This is not correct. Double check with that, right?
Okay.
Oh, this is what I think, so, I'm remembering now. So I'm not saying necessarily, they don't take anything off the model. You're perfectly okay with going with model number. Can you like to look at this?
I select model one.
Model one, yeah, it's perfectly fine, right, because that was the one that has. Yeah, that's fine. Just realize that this was really, really close, just like 0.06 or something like that.
Yeah, yeah.
I mean, if we select like 10 more participants, it's a significant difference. And so if you were to select model three, that's perfectly fine. I'm not saying you can do that, you can pick one or three. I'm just saying as a researcher, when I look at that, I'm like, man, that's really close, there's something going on. And it's not this significant, right, but it seems like there's something going on. And so you would easily justify it to select model three. I think that's my comment. I'm not saying you need to change it. I'm not saying you should change it. I'm just saying, just in practice, in real life, when you do an analysis, and it's really that close to the next 0.07, there's probably something going on there. You shouldn't have enough power to actually detect it. Right? Another 10 or 20 percent, that would be significant. Right? So you just want to be aware that you don't want to miss an important variable just because I can select it. But I'm not saying you have to change it.
For the reverse evaluation, we will need to report this on that model to expertise close to significant.
Always that up to you. You don't have to. Right? That's what I'm saying. You can use it as it is with model one, but just realize that you're using a very strict alpha. When as a researcher, I get to keep it alpha here. I can make it 0.08 or 0.012 or some random number, right? I get to see that. And then also, what would another 10 participants do? How would it over? So I think you're completely justified to say that, yeah, it's a particular activity, any credit hours, significant impact, part-time job, not a part-time job, right? But if you're being very strict with your alpha, then yeah, sure, model one works, right? So I'm not saying you have to change it, but if you want to, but just for like in practice, like if you don't change it in practice, just be aware that alpha 0.5 is like one of those constructs that we just generate. These days, good, right? It's not like maybe we can once you get your edits, I mean, yeah, well, usually, usually by this point, you see enough comments and edits that you think you could do well for five.
And I will get another chance to
Are we still recording?